Hi, I'm Manan.
Hi, I'm Nupur, and this is our project, Get Home Safe. So, as individuals from UC Berkeley, we come from different backgrounds, and we seem to have this hard transition into college when we realized that we've been seeing a lot of numbers on the local Berkeley warn me. And so we realized that Berkeley is really unsafe, and our anxiety increased. So we came up with a hypothesis. Do streetlights have an effect on the severity of crimes at night? So in a result, we performed a data analysis with access through the IBM community on historical crime data and streetlight data within Berkeley to develop predictions for the safest walking paths from point A to point B. So here's our prototype. As you can see, when you get to the home page, you can select your location and we'll offer two locations, the fastest and the safest path. And you have the choice of taking the safest path from point A to point B.
For a risk heat map, we were able to create that based on our average crime as well as our density of streetlights. We were able to create that by first cleaning our crime data and extracting the latitude and longitude with regex. With that, we were able to look at and analyze the cleaned crime data to determine the distribution of the variety of crimes. Based on that, we were able to use national crime data to assign a factor for each of the severity levels for each of the crimes, where 1 represents infractions, 3 for misdemeanors, and 5 for felonies. Based on this, we were able to use the Folium library and plot our severity levels across our Berkeley city. And as we can see, the entire area is very unsafe, with red representing higher risk as well as blue areas representing lower risk. We were then able to plot the cleaned lights as well as include the latitude and longitudes of every street lamp post, which is shown by the orange data points based on the latitude and longitudes. And as we can see, there are very dense areas of lights and less dense areas of lights as well. With this, we were able to select what is the radius of the number of lights in the neighboring area, as well as see what is a good area to determine the unsafe areas. We were also noticing that at night, from the hour of 20 to 25, we can notice there's a higher rate of crimes, which is from 8 p.m. to approximately midnight, as well as later into the night as seen by the densities of this violin plot. Based on that, we were able to use our radius and influence by dim and unsafe areas determine our boundaries for what are the number of neighboring lights as well as our crime risk. Based on this, we were able to create a risk factor, which was based on the areas that are in the radius, as well as based on the block system and the heuristic that we created for 75% representing our crime risk, as well as 25% representing our clean lights. And based on that, we were able to determine and create a histogram of our count of our risk factors, which, as we can see, there are many from the range of 3 to 5.
So going further into our risk factor, we wanted to compare our light risk versus our crime risk that we have calculated. And as you can see in our graphs further down, in our scatter plot that we have shown, if you see from the crime risk from 3.5 to 4, we can see there's a higher density of crime when there's only 0 to 10 streetlights, versus if there's more streetlights, there's less density. We can also see that in our joint plot that at 4, at the crime risk of 4, there's a higher density from 0 to 10 lights.
We were also able to create a linear regression using the scikit-learn model. And through that, we were able to use the features of latitude, longitude, number of lights, and wattage, as well as the bias term, by first splitting our data into our training and test set, then pipelining the data and fitting the model, and predicting crime risk. Based on that, our RMSE was approximately 0.43, and as we can see from the linear regression, the factors of number of lights and wattage did not have a significant effect on our crime risk, with our 0.008 term here. So we discovered there was no major mathematical correlation.
However, we did conduct some user interviews, and we've realized that psychologically, people still feel unsafe in Berkeley. We've interviewed 10 people in Berkeley, and here are some responses on the slide. But we also realized that the user interviews was a confounding factor that we could not include because the features do not capture live foot tracking data, which is unavailable at the time.
And with this, we use our tech stack for Pandas, Matplotlib, Folium, GeoPy, GeoCoder, and SciPyKit for our linear regression.
So next time you're walking alone, make sure to get home safe with
With Get Home Safe.